interrupt me if you have any questions, and I will get started. As an NLP expert, the goal for us is to enable users to access a wide range of information that's available for us. In the libraries, in the web, there are so much information out there, and we would like to be able to access that effortlessly. And question answering is really a flexible and intuitive interface to access such knowledge. So whenever you want to know about something, you just pose it as a natural language question, and then the machine ideally will get you the answer that you want. So this has been a focus of my research in the past 5 to 10 years. And I'm going to briefly talk about how we've been studying this problem since about 2016. So we framed this problem of question answering as a reading comprehension. So how it works is we have this question that we are curious about, and we have this document that contains the answer to the question that you are posing. And all the model has to do is find the span in the document that's the answer to the question. It's a fairly constrained setting because you are given this document that contains the answer. You just have to find out which part of the document answers the question. And we have seen a very, very strong and rapid progresses in this reading comprehension setting in the past 4 or 5 years. So we evaluate the predicted answer span and then the reference answer span and check the word overlap. So that's the F1 score over there. And you could see from 2016, the model is going better and better and better, and now surfacing human performance on this reading comprehension setting. And a lot of this progress has coming from bigger models for better representation of text. Like BERT, GPT-3, if you have heard of those keywords, those were really driving these progresses. So we are so excited about this and now trying to make the task more realistic. So instead of providing the evidence documents, so we are seeing this kind of hypes. And then instead of providing the evidence documents that contains the answer, we are now making the task harder and more realistic by getting rid of the documents and just make it as an open retrieval setting where you are just giving the question and model now has to go out, find the documents, and then answer the question. Now the task is kind of embracing the word knowledge. So it has to know about the word, how word is changing, and so forth. And let's talk a little bit about how we are collecting the data to study this problem. So we start with collecting questions, either from popular search queries, or we ask crowd workers to come up with a list of questions that they're curious about. And then we use the search engine to find the top articles. And then from the top articles, we let the annotator to find the answer. So even though we wanted to try in this open retrieval setting, we are not actually exhaustively looking at all the pages on the web. We look at the top articles and then find the answer according to this snapshot of a single Wikipedia article. Then we also throw away the questions that cannot be answered by these top articles or if an answer is too long. So this is the setup we are studying, and after we collected this question-answer pairs, we kind of put the word in the middle and study this problem as if the correct answer to the question remains constant. And secondly, we also train the model in this question-answer pairs. And once the model is trained, we put it as static, and we rarely update the model that's deployed in academic settings that we are studying. And then lastly, we are also assuming that a lot of questions that we study can be answered with this short, concise span of text. So in this talk, I'm going to talk about the missing pieces, the simplification that goes into current framing, and how are we going to make this task more realistic. So I'm going to talk about the first missing piece, which is the dynamically changing world that we live in. So let's look at these 3 questions. When did the latest Kendrick Lamar's album come out? Who is the interim prime minister of Pakistan? How many planets are there in the solar system? And any guesses on like what's common about these questions? Yeah. So knowing how the word changes is necessary to be correctly answer such questions. So when you go to this open retrieval word, we should really start thinking about this dynamic word. And I'm going to talk about the second missing piece, which is diverse user scenarios. Here are some other questions. Which COVID vaccine is approved by our government? How long is a typical wedding ceremony? What are the similarity of these questions?
That's where you are, the answer.
Yeah, so here the correct answer can change based on who is asking the question, where they're asking the question. And also for some questions, I'm not going to talk too much about this part in today's talk. How do you present the answers should also vary based on the user scenarios. Like, are they this person asking on the on the computer or on your phone, or is the person who's asking has a lot of knowledge about this particular topic or not? So the answer should be flexibly composed based on the scenarios of the users. So I've talked about dynamic word and also various user scenarios. So the model has to be able to evolve and adapt to both the word and then the users. So in this talk, I'm going to talk about our various efforts to go through these directions of more modeling dynamic word. So in the first part of the talk, I'm going to talk about how can we do open retrieval QA in this dynamic environment where answer to the question varies based on the time or geographical context. And then secondly, I'm going to talk a little bit about improving question answering system through user feedback after its deployment. And then in the last part of the talk, I'm going to talk a little bit about going beyond the short, concise span that's easy to evaluate, something that we understand very well, towards going through this multi-sentence answers that's very complex and interesting. Okay, with that, I'm going to move on to the first part. So this work was presented in MNLP 2021, Situated QA, incorporating extra linguistic context into question answering. Work with my first PhD student, Michael Zhang. So we are really interested in studying these temporally and geographically dependent questions. So first question, where were the last Winter Olympic Games held? If you're asking this question today, the answer should be Beijing, but the data set that we are using are collected in 2018, thus annotated as Pyeongchang. Second question is geographically dependent because of the we over there. How many gold medals did we win in the Winter Olympics 2018? So it really depending on where is this question posed. So we're interested in studying this question's dependence on extra linguistic context. So we're interested in modeling these two parts and further studying how can existing model handle this context-sensitive questions, and how can we build models that can better handle this extra linguistic context more gracefully. Because people haven't really looked into this problem, we first had to go through starting to collect the data. So where we have this question, and in addition to their temporal or geographical context, and then the answer that's dependent on both question and then the context. This is the data that we are trying to collect. And we first started looking at the existing data of open retrieval question answering, and we actually found that these temporally dependent questions were quite common in the existing data. So all we have to do is just ask annotator to mark temporally dependent questions and collect multiple answers for that questions. For geographically dependent questions, these questions were not collected during data collection because people found it ambiguous and there was no single answer, and they were not collected. So we kind of simulated geographically dependent questions by getting rid of geography marker from the question, and then now we end up with the geographical dependent question. We found the questions, we identify where they are dependent or not, and if we find they are dependent, then we collect multiple context answer pairs. And then we went through a validation phase as well. We did this for geographically dependent questions as well as temporally dependent questions, where students went through crowdsourcing and collected about 5,000 of each kind. Now I'm going to briefly talk about the data statistics. First thing that I would like to talk about is like what's the percentage of temporally dependent questions in the existing data set that we've been studying in this open retrieval settings. So we looked at 4 data sets that's out there, and in all data sets, at least 10% of questions were temporally dependent, and for some data sets, it was up to 30%. And then also we looked into how frequently the answers are changing, when answers are changing, and there was a long tail distributions, but about half of the questions were changing about within a year. Now we have the data. I'm going to talk a little bit about building a system that can answer this context-dependent questions. Feel free to interrupt me with questions if you have any in the middle. So now we have the situated QA data. And the model has to know about which geographical or temporal context it is in. And we took the simplest approach possible, which is just attach the context as a string to the original query. So when it's temporally dependent, we wrote it as question as of this certain date. And then for geographically dependent, we just added in as in the geographical location, kind of recovering its original forms. And then we experimented with the 2 state-of-the-art models for question answering. So as a brief background, there are kind of 2 approaches to solving question answering these days. So the first is closed book approach, and it's what you're thinking. So it's like you're giving an exam to the students and they are not allowed to look up any resources. They have to answer the question from the memory that they have. So how it's working is encoder-decoder model that takes the question as a sequence of tokens and generate answer as a sequence of tokens. So it has to really remember everything about the answer in the model parameters. Sequence-to-sequence model. And then the other types of models, retrieval-based model, which consists of 2 parts where you can retrieve relevant documents, and from the relevant document, you can answer the queries. So we are evaluating these 2 approaches and have 2 settings. The first setting, 0 shot, is you only see questions that doesn't have this location or temporal context attached to it. So just regular QA pairs, the 0 shot setting. And then the fine-tuned setting, you further train the model with these questions with as of something or in something type of questions. Is the setup clear? Right. So yeah, 0 shot performances are lower, but it could still make a reasonable guess, like who is the president, and it's gonna make a reasonable guess of what it is, even though you don't specify the. But yeah, it could be according to all data or common locations. So we are evaluating. We are kind of trying to see which model does better. So we are looking at models' performances of each of these systems, but we could totally think of ensembling those to utilize both approaches.
So basically, the same model uses search.
Yeah.
Or a search engine. Find and kind of semantic search for data vectorization to be added to the closed loop answer.
Right. So yeah, the second approach is basically have its internal search part. We don't use the black box model, but have kind of lexical matching system. So they look for relevant documents, and from that relevant document, it does something similar to closed. Well, it's not closed book anymore. It's looking at the documents and find the answer inside it. Oh, yeah, the retrieval-based approaches are usually performs better, and that's what we see here as well. So the orange bar up top is human reference performances, and it's pretty low because we are doing exact match with the annotated text, but sometimes there are different forms of answers and so forth. So yeah, but for reference point, that's the human performance. And then what I was trying to show in this graph is that the blue are the questions where the answer doesn't change over time. And the yellow are the questions where the answer change over time. And you could see that both approaches suffer more when the answer changes over time, even though you provided that context, the temporal context into the query. It kind of shows how existing models are not that good at taking consideration of this temporal dimension.
Is there also a consideration that the data set itself is incomplete, that it already doesn't have the temporal context, like it's simply out of date? Or like if we want data from 2022, we probably wouldn't have it, right? Or is that an issue why it's leading to this suffering with temporally dependent data or temporally dependent questions?
Yeah, it's definitely a part of the data as well. Later, I'm going to show results of like we are training only from the data from 2018 and test on the data from 2022, and we also see degradation over there. So there's like multiple things that goes in there. Yeah, good question. Okay, now I'm going to move on to geographically dependent questions. And here, how we split the result is the location that occur frequently during the training data and the location that didn't occur frequently in the train set. So common location and rare locations. And unsurprisingly, even though it's asking exactly the same question, asking the same relation, who is the president, if you ask who is the president of the United States, the model can answer well. But if you ask who is the president of some country that's rare, then the model performance drops significantly. And you can see that how much it drops also depending on types of the model. So the closed book model where you have to remember instead of looking up actually shows a lot worse generalization to different geographical locations. Uh-huh.
Geographical questions. For example, if I'm asking about the president of the correct answer, there is no president, or is the correct answer, UK has prime minister is this person?
Great question. So those are that's called presupposition. So sometimes the questions are ill-formed, like who is the president of UK? And in this data set, because we are collecting the data for people to provide this multiple location and their valid answer, so we don't have such ill-formed question in this data. But unanswerable question is really big thing that we are not studying very much, and we actually had an analysis paper because we're actually throwing away about half of the question because they are problematic in that sense. So that's another direction for future research. Okay, so these are geographically dependent question answering. So we kind of see that both temporally, geographically, our models can do better and should do better. And now I'm going to talk a little bit about temporal adaptation. So a lot of times you don't really specify the time because we all assume that when you're asking some question, you assume that your answer based on the present, right? So that's the standard question answer setting. But then we collected this data in the past and we keep reusing it. So here what we are trying to study, our training data is question answer from 2018, and if you test on testing data where the answers are of 2022, how well does the model do? Was that clear? And before, we didn't really have to think about it too much because the data set and then the model and then the Wikipedia dump, the pre-training, all the data were kind of around this similar timestamp of late 2018, early 2019. But our situated QA data, which has the extra time mark, it was collected about 2 years later. So we could kind of see this breakdown of questions that the answer has been stable since 2019 and questions where answer has changed since 2019. I'm sure there must be a basketball fan somewhere who knows where Jeremy Lin left. So we are kind of going to compare the performances of those stable questions versus updated question, where updated question, you really have to have updated knowledge about the word. The closed book model, which has the memory of 2018, which just remembered stuff from 2018, has very little, show really giant drop in performances answering these new questions, which kind of makes sense. It hasn't seen the newer word. So those kind of sanity check was not doing very well. And then we move on to the retrieval-based model. And we thought the retrieval-based model has a better hope because it's using this Wikipedia dump as a retrieval corpus where it's gonna find the document. And we thought that we could just like swap the document into the newer retrieval corpus, and then the model should be able to answer the questions from the later part. Unfortunately, the performance was still pretty bad if you swap it into, even after you swap it into the newer documents. But if you further train the model with these questions from 2022, then the model starts to show some improvements. But overall, collecting the data from the past and then updating to the model to understand the present are problematic in both closed book and retrieval-based QA model. And there, it kind of, I think there should be a lot to study in this temporal generalization.
So what's the problem? Is the problem that the search algorithm through the documents is bad, like it doesn't adapt? Or is the problem that the actual like method to go through the document doesn't work with the data?
So both, so we actually decompose into whether it's failed at the retrieval phase or at the answering phase, and it's kind of both, but retrieval is usually harder. But it's like still, these are trained model on this data from 2018, so it remembers a lot of prominent entities from that time period, and it's like, it loves to answer those entities. So, you know, given that we've been,
You could try to combine the benefits of both this approach, right? Just maybe like updating the closed book model with some like of the query results and see if the model gets better. Are you going to talk about this at some point? Or?
I'm not going to talk about it, but it is true that the state-of-the-art, the very best model these days are using some of combination of both. So it retrieves the documents, and from that retrieved document, it generates answer token by token. That's kind of state-of-the-art models.
Nice.
Yeah. But given that we are suffering both in dimensions, I think that model will also gonna have similar performance drop on newer questions.
Okay, thanks.
Okay. So given that we are training this really large scale language model and then kind of stayed fixed, and the world is changing, there has been a lot of other work, people looking into time-aware language models. There's work from this temporal generalization of language model from DeepMind. So, and how can we edit the models, continual knowledge learning of the language models. There was this new workshop coming up at the NLP 2022 about evolving NLP. And there has been less focus on the geographical question answering, but there has been some work looking into common sense questions where the answer varies across the location, and how can we better model this. And our data set is kind of unique that A lot of these are kind of looking at synthetic data, but we are looking at the real search questions derived from search queries and studying both geographical and temporal context. I'm gonna skip this. Well, I can briefly talk about it. We had this like a follow-up work where we are looking into this newer entity that arises. So, you know, Emily in Paris, hurricane, some new companies. So trying to see how much model knows about these newer entities. So we've been looking a little bit about this unseen entity settings recently as well. With that, I'm gonna wrap up the first part about situated QA. Really, as we go through this more realistic scenarios, we cannot just simply ignore temporal or geographical context and more carefully model this aspect for studying question answer. With that, I'm gonna move on to the second part. Any questions before I move on?
What do you do in fine training? What is the difference in
So
fine
fine-tuning phase, meaning that we have this question. So for the temporal, for the situated QA setting, to fine-tuning means we have this question with augmented context and then answer pairs and train model on that data set further.
That makes sense.
I can chat later, yeah. Now I'm gonna move about talking about updating the model. So this is a new work, joint work with Gao and Yuval Arts at Cornell Tech, and to be presented at ACL in a few weeks. And by now, I hope I have persuaded you that updating model and updating our data set is inevitable in dynamically changing world. And the question is, how are we going to update already trained model? Here, what we are trying to study is we deploy the model and then let user provide feedback on the model predictions and then update the model based on that user interactions. And the reason for it is if we keep collecting data, you know, data collection is usually costly, and there are some artifacts that comes with it. And also if we really reflect the user scenarios, then it's gonna be more realistic. So that's kind of the idea of how can we learn from users' feedback instead of static data that we have collected in the past. Because now we are moving to a more challenging setting, we kind of take a step back and don't do this open retrieval question answering and do extractive question answering, reading comprehension where you are given the documents. So this is an easier setting now. And user asks a question about the passage that's provided. Model provides an answer as a span in the document that's provided. And then the user provides a feedback to the model predicted answer, whether it's a correct answer or incorrect answer. So we do a very simple binary feedback, thumbs up or thumbs down. And then the model will update its parameter based on the feedback to improve itself. Disclaimer here, we actually didn't really deploy our model, but use existing supervised training data to simulate the user feedback. So we have this annotated question passage answers, and then when the model predicted answer matches the annotated answer, then we set the feedback to be 1, minus 0.1 otherwise. So we are simulating this user feedback scenarios. Great question. Yeah, we had the simulation set up later about the noise level. And it's kind of interesting because like the original annotation data, some of those data is noisy inherently. So there's some noise already, but then we introduce further noise and see when the model starts to collapse. Yeah. Okay. So that's the setup. I'm gonna take a brief comparison to dominant paradigms for question answering where typically we just do this discriminated supervised learning where we are learning to predict answers given question and passage from question, passage, answer triples, a lot of them. So we do the supervised training. And in this setting, we are framing as contextual bandit problem. Instead of answer, we have question, passage, predicted answer, and the feedback. So this is the learning signal that we are going to use. And then because we need to make initial prediction, we start with initial model that's trained on a small amount of in-domain supervised data. And then we're gonna go through simulation and see the model performance improve. It's actually the real graph from squad dataset. That's this kind of the dataset that I showed at the very beginning of the talk. Okay. So learning algorithm, we use pretty simple setup. Question, context, pi is the model that returns the predict the answer. And then the reward is as defined before. 1 if it matches the annotation, minus 0.1 if otherwise. And then we compute the gradients and update the gradients using the holistic gradients. And we do this training across the training data that we have. Pretty simple setup, but yeah. Later, we are currently working on doing more realistic simulations.
Like you talked about like experts versus like, let's say students, let's say. But here you're not assuming that, say there are clusters, groups of users that might have different expectations.
We are not doing any of those interesting things. This was very initial work, but it's going to be very exciting to explore like modeling different types of users. Yeah.
I see. Okay, thanks.
Even though we're testing the simple setup, we at least try 6 different types of question answering data sets. Some are question answering from Wikipedia, some are from news articles, some are from web articles, and then evaluation metric is whether it matches the annotated answers at the word level. And we use this variant of BERT model as a model architecture. Now I'm going to show the results. So the red number is at the initial model that's trained with 64 examples or 1,024 examples. So those are kind of small amount of training data and then the initial performances. And then the gray bar on the top is if you use all the data as a supervised training example, then how far the model gets. And then now I'm revealing the result from this bandit learning simulation performance. Even though it doesn't reach the supervised training performance, it can show pretty impressive gains from the initial performance throughout this learning from binary user feedback. And we could also see that much of the learning happens earlier during the training. Because it's a user scenarios, we don't only care about the final performances, but how rapidly does it get there, because user suffers while it's giving feedback if the model is not doing well. Questions? Okay. This is on the easiest data set, and we kind of look at the 5 other data sets, and overall we see on this Wikipedia domain data set where the supervision, the training data was pretty precise. The model works pretty well and recovers. It doesn't really recover the supervised learning performances, but it improves its own performances over time fairly well. And then when we move on to this more challenging data sets, we see not as nice of performance gains. And a lot of it, I think, is because the supervision signal here, the reward, is based on the distance supervision. So it was not human annotator annotated this question and answers for the questions, but they found the web articles that contains the answer and assume that article contains the reasoning, correctly answers the question. So the data itself was kind of noisy. So this is the setting that where there's a lot of noise, and when there's a lot of noise, the model doesn't learn as well. It's kind of more sensitive to the noise than the supervised training as well. So far I've been presenting results in the online setting where we are giving model feedback of like one question answer pairs, and then the model updates its parameters, and then do it so model gets updated like every time we see an example. This is somewhat unrealistic setting at deployment because it's pretty expensive to do this at every single example. So in the paper, we also try this offline setting where we gather feedback on a lot of examples, and then later on use this feedback to update the model at once. So that's the offline setting. There are details about pros and cons of online versus offline. I think combining both will be also interesting direction for future. Online learning works better when the feedback signal is noisy. Offline learning can yield better final performances when the initial model performance is strong and then the signal is not as noisy. Those kind of in-domain results, and we also experimented a little bit about domain adaptation, where we assume we have this training data, large quantities in different domain, and we are deploying it in another domain and like learn from this user feedback. So here we are looking into train initial model on existing data set and then update on the target domain. So these 5 different data set, that's the initial data set, and then we are evaluating on this data set called Hotpot QA. And because of domain differences, sometimes the initial performances are pretty bad. So if you train on Trivia QA and evaluate on Hotpot QA, the initial performance model is like almost 0. But then after simulation, the model can gain a lot of performances and get up to like 73, which is pretty impressive. So we tried this on 30 configurations. We were able to observe some gains on 22 out of 30 configurations. And where it fails is on those data sets where this supervision is noisy. And when the domain shift is big, then we were also seeing more degradation in performances.
When you say it's noisy, what kind of features contribute to that noise?
So the training, so we are using this supervised training data to simulate the user feedback, right? But then the training data itself was not, the question answer pair sometimes was not correctly paired. Yeah.
Thank you.
Okay. With that, I'm gonna wrap up this part. It was kind of a very new approach that we are taking to this bandit learning instead of doing supervised learning for question answering. We were looking further into simulating more noise and how robust is the learning towards that. And also do some regret analysis, looking at like how much users suffer during the simulations. I think there's a lot of room for further research here, like what kind, instead of binary feedback, can we provide like, natural language description of why this is incorrect, or yeah, so I think there's a lot to be studied here. And with that, I'm gonna move on to the third part if there's no questions about this. Okay. So last part, I'm gonna move on to even more ambitious part where we are like trying to go beyond the short, concise span of answers. This is a joint work with Fang Yan, my student-to-be, and Jessie Lee from Linguistics Department at UT. And this is going to be presented at ACL in a few weeks as well. How do we answer complex questions? Discourse structure of long-form answers. So far, we've been looking at those kind of short, concise answer spaces. And we are trying to go study this like when answer is lengthy. And yeah, so before we were looking into the short, concise question, now we are going to this long form answers. And there's like a lot of reasons for why do we want to go to this long answer regime. Anyone? Why should we study this problem compared to the short ones? But more context, yeah. More interesting questions, yeah. So some questions are inherently cannot be answered by short spans, right? So if you ask about causal relations or hypothetical situations or procedural knowledge of like how do I cook something, you cannot really answer with short, concise text. And even for simple factoid questions, there are ambiguity that arises. And like for example, what's the typical shoe size, right? It's a simple answer, but then it depending on whether you're asking shoe size of a man versus a woman versus a child. So there are ambiguity in the question itself, even though the question itself was fairly simple. So even for simple questions, long form answers can be useful. And also, sometimes it's better to provide where the knowledge is coming from, like, and so forth, and limitation of the answers. So yeah, long form answers are pretty useful in both addressing complex questions as well as complex answers to a simple questions. But then there is a reason, why we haven't been studying long form QA for a very, very long time. Oh, actually, this was not on. I guess it's okay. So even though there are like thousands of papers on question answering, I think there could be at most maybe 20 questions on long form QA. And one of the main reasons is dataset is really noisy. So the dataset that we've been using for long form QA are this question and answer pairs collected from subreddit from 2019. So answers are very noisy. And evaluation is also really challenging. So for short form QA, we could do this automatic metric on this. This is the reference answer, this is model predicted answer, and compute the overlap of the words, and that's pretty good estimate. But for long form QA, it just doesn't work. And even humans suffer at evaluating which answer is correct answer, because unless you know about this question topic, it's really hard to know whether the answer is correct. And you have to do this correctness and fluency evaluation at the same time. Both are really not trivial. So at the beginning, when we started this project, we would like to, I want to solve long form QA, but then we were like we were doing A/B testing, and even humans were not reliably selecting which answer is better. So we took a slightly more modest goal of trying to understand what's going on in these long form answers. And specifically, we are asking this question of what purpose does each sentence in the long form answer serve to answer the question? With the long-term goal of that if we understand the long form answers better, then we could better design the evaluation protocols as well as design how to generate the answers better. This is our research question. What purpose does each sentence serve to answer the question? So when you are writing scientific papers, there are some sentences that belongs to background, some sentence that belongs to methods and so forth. So we are kind of trying to find similar structure in the long form answers. And we develop an ontology of 6 functional laws for long form answers. So I'm gonna go through examples to show those roles. So here is one long form QA example. Why does salt bring out flavor in most food? First sentence, salt does a couple of things that add the flavor of foods. it's really not answering the question. And that's one of the reasons why like lexical match-based answer evaluation doesn't really work, because there are many sentences that's kind of this functions. We name this function as organizational sentence, as some sentences that inform user how the answer will be structured. And here are some other examples. And then some other sentences are actually answering the question. So you name them, we name them as answer rules. And we kind of distinguish them into two sub-rules. One that's more salient information, which is a summary, and the other that's elaborating the earlier sentences as a regular answer. So in this example, we see organizational sentence, answer, summary, answer, answer, summary, answer, answer, summary, answer. Now we're going to question about the sugar. The second and third sentence is the answer summary in this example. And if you look at the first sentence, it's not actually answering the question yet, but it's also not an organizational sentence. We name these kind of sentences as auxiliary information, which provides background or related information to the question and the answer it's trying to compose. We have three more roles. One other role that we found really interesting was examples. Sometimes people bring up hypothetical or real examples to compose an answer. And we actually have a whole follow-up paper studying further into these examples. Some examples are from personal experiences. Some examples are hypothetical. There's a lot of interesting linguistic phenomena that goes in there. And then lastly, we have this role of miscellaneouses. It comes a lot from these Reddit answers, pointing towards where the source of why you should trust my answer, sentiments about the questions and so forth. Yeah. Now I have defined 6 functional roles of long-form answers, and I'm going to show some statistics about the data that we have annotated. So I said the data is a kind of big bottleneck of studying this problem. So I'm going to talk about the data set that we currently have. The first one is Li5, which is taken from Reddit, explain like I'm 5 forum. Second is really recent work from OpenAI. So they ask human annotator to browse the internet. They provide this small search API so they can look at documents, and from that documents, they ask the annotator to compose a long-form answer. So that's that data set. And lastly, we are going to also use question answer data set where answer is taken from paragraphs in the Wikipedia. But these were cases where there are annotators saying there is no short, concise answer, but this paragraph answers this question. We annotate about 500 answer paragraphs, about 3,000 sentences. It was a pretty difficult task. Whenever it goes paragraph level, crowdsourcing doesn't always work very well. So we actually hired undergrad linguistics students to do this annotation. And here are our distribution of the roles in the data set that we study. So the pink is a summary. The orange is just a regular answer. Green is the auxiliary roles. Blue is examples. Yellow is miscellaneous. And then the gray is organizational sentences. One thing that I noticed is that about 40% of sentences serve rules other than directly answering the question. And if you look at these 3 different types of data sets, you kind of see the distribution varying. Yeah, so Li5 obviously has more miscellaneous sentences. The Wikipedia-based natural questions or WebGPT doesn't have such miscellaneous sentences, but then more auxiliary information. So now I was looking at the human composed answers. We are going to look into the model generated answers. So we are using the state-of-the-art Longform QA system, which retrieves some Wikipedia documents relevant to the question. And then from the retrieved documents, we are generating the answer. So it's like the combination of closed book and retrieval-based approaches that I was talking in the earlier part of the talk. And then one thing that we have noticed is we are using exact same set of annotators. The annotator doesn't know whether it's coming from the model or coming from humans. But when annotators were annotating the model-generated answer, they suddenly started to disagree more among each other. So the sentences are less clear which role it is serving. So the percentage of disagreed sentences raised from 9% to 17%. And then also the generated answers contain less examples, less summarizing answer sentences, and more auxiliary tangential information. And this model, actually, even though I say this, it seems pretty obvious that it's doing worse, but if you actually take the comparison with this lexical overlap, this model does as well as the human reference answers, according to automatic measures. So like looking into discourse structure can actually reveal the gap between model-generated answers and then the real human answers. That's all I wanted to say about the last part of the talk. Longform QA is really exciting new direction for future research. But there's a lot of complexity that goes into it. It's now really a discourse structure that you start to have to model. We did some model building as well for building model that classifies roles of each sentences. And in domain, models perform pretty well. If you go out of domain, the model cannot assign the roles properly to the sentences. Yeah, and we are trying to think about like how can we better solve this Longform QA problem moving forward. With that, I'm kind of trying to summarize what I was talking about today, going beyond this assumption that the answer to the question stays constant, and the model that we are training stays constant, and also going beyond this like short form answers, missing pieces of this modeling this dynamic world, as well as diverse users and their scenarios, and then building the model that can evolve over time. And for those of you who are not just about question answering, I kind of want to talk a little bit about just in general what's happening in NLP in these last few minutes that I have. So I've been talking about, we are looking at this reading comprehension where the answer document is provided, and now we are moving towards this open retrieval where you have to go find the answer from this like open setting, right? And this is not just the question answering. Actually, this is happening all over NLP. Before we were looking into this more constrained task like sentiment analysis or linguistic structure annotations, where if you understand that snippet of the text, then you can do this task very well. But in 2022, these days we are studying this more complex task involving fact-checking, common sense reasoning, logical inferences. So the benchmark that we're studying these days combines this a lot of word knowledge at the same time. So many NLP tasks in 2022, it really requires adapting to a dynamically changing world. And with that, I would like to end my talk here, and would like to thank my amazing students and collaborators, and I'll be happy to take more questions.
If anybody has questions, we have a microphone here, so also downstairs.
Yeah, question is whether we do question generations, not just answering the question that's out there. Definitely there has been more and more research about question generations as well. And yeah, they do tend to help to improve model performances. Yeah, I mean, it's costly. So this is a lot of things. It's like, how much can you get from the resources that goes in there? So question generation usually requires you have to generate and then you have to train more on that data set. So that's a bit unsatisfying, but it does show performance gains usually. Yeah.
So for the last part of the talk, like, is the final goal to take like a document in the open world and then build an answer that would have all the components that you're trying to find, like the example, the structure, like, is that the final goal, like that? Or do you envision that to be possible so that someone asks a question and you know kind of what the good answer should contain, right? Should have like the actual answer and then there may be a summary, examples. And do you think you'll be able to sort of like collect that from a document and sort of like build the answer accordingly? Is that one of the things that you want to do?
Yeah, so definitely, like one of the goal of understanding this discourse structure is to build this more coherent answer. You know, at the beginning, you should summarize your answers and then later provide examples and then auxiliary information or so forth. So that's one goal. The other goal that I was really interested in was about evaluation. So for example, this is the reference answer, and if you miss the example of that reference answer, it's not that big of a deal. But if you don't get the summary part, then it's a bigger issue, right? So kind of trying to use this discourse structure to design better evaluation mechanisms is one thing that I envision doing, yeah.
And then the second question is like, what is your next step for the personalization part? I think that part was very interesting. Like you right now you're just updating the model based on feedback from the user, right? So do you have like how you could improve that? For instance, I'm thinking that, let's say, for instance, if I could collect some answers that were correct for a given user, I could try to match users now and then sort of like reuse, right? So kind of cluster the users. I guess this idea, when you talked about like personalization, I thought that you have some sort of like profile, user profile or something like that. So have you done that, or have anyone done that?
Yeah, so I think that's like, I think for me, that's like maybe 3 steps ahead. The first step that I'm trying to look into is like, can we compose different level of specific answers? So can I give a 1-sentence answer, 2-sentence answer, 1-paragraph answer? And even that is, we don't know how to do that very well. Yeah.
Thanks.
Yeah, so I was kind of wondering how much of, when you have sort of these contextual questions you're trying to ask, especially with the retrieval-based methods, how much of that is that you have different documents that say conflicting things, and it's really sort of having methods that can choose which one is actually relevant? I mean, or how do these, you didn't really go into the technical sort of underlying, but how do these retrieval methods deal with that? If I have 10 documents and they each give a different answer to who's president.
Yeah, that's a great question about like, how do we model which document is a good document? But I think I kind of insinuated at the very beginning of the talk, all of these data sets are collected with annotating this top retrieved document. So that's the answer that models should be getting. And because the data was constructed that way, so the model will be only get points if you get that top document answer. So actually one of my students is looking into like, can we actually retrieve multiple documents where we can see kind of contradiction among the documents? And when there is contradiction, what's the ideal model behavior that we should see? Should the model abstain from answering or try to provide a list of answers with like kind of accompanying documents? So yeah, I think there's a lot to be done over there as well, especially given the like, misinformations and so forth. Yeah.
Right. Well, I guess what I was getting at is that for certain questions, right, like any of 10 documents could be right. If you ask who's president, well, you could get, President Biden, President Xi, President Duterte, or whatever the guy from Philippines is named, right? Like, so it really seems like this is closely intertwined with this whole contextual thing.
Yeah, it is definitely intertwined with, And questions are like surprisingly ambiguous if you start to look really closely,
You have documents that change over time, or things that change over time. How you handle that? Like for example, the president or the Olympics, the number of medals, or the temperature in a valve over time, or the temperature outside in the per hour. How you handle?
Yeah, so currently how we are handling it is we just inject that information into the question. Like, who was the president in 2012? Who was the president in 2018? And then just let the model do whatever it wants to do.
For the long question answering part, you annotate it as like example, summary, organization. So who is doing that? Basically,
Undergrad linguistics students at UT Austin.
like, is it human annotated?
Yeah.
Okay.
Yeah.
I get it.
If we later build a model to do that annotation automatically, and once we train on like 500 examples, the model can predict it pretty reliably as long as it's from the same distribution.
Maybe I can ask a question too. So, especially when it comes to long form question answering, you're generating text. I mean, like a paragraph or maybe longer than a paragraph. And you're characterizing the text as, here is a supportive statement or, auxiliary information, etc. How is this related to techniques people use for summarization? In instructive summarization, you also go to a large, maybe piece of text and you start to rank sentences based on relevance, and try to put them in a coherent way. Is this something that can be used in a similar fashion for something like summarization instead of long form answering?
Yeah, definitely. There is a very close connection to the summarization, but in summarization, you don't have additional input. You have a document and then you are trying to get to a summary, right? And in this setting, you have a query as kind of conditional about like what aspects of this long document that you have to focus on. So in a sense, I think some people use term the query focused summarization. Yeah.
Right. I mean, especially with the retrieval-based approach,
Yeah,
it does
definitely.
approach the task of summarization pretty closely, right? Okay.
Yeah, but as I said, like some questions are asking about like hypothetical situations and so forth,
okay.
and then those things there is nothing that you could summarize. You have to really invent answers. So
I see.
yeah.
All right, thanks. Well,
Thank you for everyone. So yes, please.
thanks.